All right, probabilities of draws with replacement. So an urn contains 7 black and 5 red balls. 4 balls are drawn randomly from the urn in succession with replacement. This means they are put back, or it's independent. That means that each individual probability doesn't affect the next one, okay? That is, after each draw, the selected ball is returned to the urn. What is the probability that all 4 balls drawn from the urn are black? So, what is the probability that 4 draws are black? Okay, and this is a really poor way to write this. What we'd usually write is, what is the probability that you draw black, and then black, and then black, and then black? And when you see an and, this means you multiply our probabilities, right? So you'd say the probability of a black times the probability of a black times the probability of a black times the probability of a black. That's what we're looking for, okay? So what's the probability of pulling a black out of there? Well, the probability of black is 7 out of 12. So this would be 7 out of 12 to the 4th power, because we're going to end up taking it times itself 4 times. You could write it out this way too. 7 over 12 but it's way faster to write it this way, to the 4th power. Okay, and then we're going to grab our calculator and we're going to write that out. 7 divided by 12, and we're going to say to the 4th power. And now they have said round it to 3 decimal places. Oh, so 3 decimal places is going to be 0.116. And that is your answer, 0.116. So it is an 11.6% chance that you will draw 4 balls and they will all be black. Okay. Now here, this is the other kind that we're going to get. This is what we call a complement. Should be looking for these style. A fair die is rolled 4 times. What is the probability that a 3 is obtained on at least one of the rolls? At least one of the rolls. It means that you're going to roll it 4 times. 1, 2, 3, 4. And only one of them has to be a 3. Could be here. Maybe it's here. Maybe it's here. Could be both here. Could be all of them. Okay, so this one is more tricky because you don't know where the 3 is going to be, when it's going to be, how many there's going to be. And because of that, we need to start thinking about what's the other scenario. When would we not meet this requirement? And it would be when none of them have a 3. So what's the probability that there are no 3s? And a complement says you can find the probability of at least 1 3. It would be 1 minus the probability of no 3s. That's what a complement tells us. Okay. So now that we've got our scenario set up, we're going to do that, okay? So we're going to do 4 rolls, rolled 4 times, okay? So our probability is going to be equal to 1 minus, what's the probability of no 3s? Okay, probability of no 3s. Okay, so the first time we roll it, what's the probability that there's going to be no 3s? Well, it's 5 out of 6. What's the probability that we roll it and there's no 3s the second time? 5 out of 6. And this third time, 5 out of 6. And the fourth time, 5 out of 6. So it's going to be equal to 1 minus 5/6 to the 4th power. If we grab our calculator, we can type that in. We can say 1 minus 5 divided by 6 to the 4th. And the probability of at least 1/3 is equal to 0.518. And that's what you would type in, 0.518.